some stuff to help make your environments a little bit more immersive. Here's a sample scene that I whipped together this morning that has a couple of things in it. It's not the most compelling thing I've ever made, but it's a little bit more immersive than what we've seen so far, right? We have some sound, we have some very basic dust particles, we've got a nice little blur and some lights and a background, and all of this took me about half an hour, 40 minutes. It's pretty easy to get this stuff up and running once you kind of know how to do it. The things that I think are not particularly immersive about this are I was pissed off this morning because I couldn't get the ground to look very good. I think the ground looks sort of dumb and the desks look kind of low poly. But that's just a matter of fact. That's like because the models that I found themselves are like low poly models. But if you got very photorealistic models and you spent the time to set up the textures and the materials properly, you can get very realistic results. Okay, so all of that's to say is there's a couple concepts and nodes and workflows I want to show you. I want to show you about basic lighting. I want to show you camera attributes, and oh, there goes the sound. I want to show you sound, or I want to hear you. I want you to experience sound with your ears. So lights, cameras, sound, and I did last week mention the glories of the animation player. I'll show you a little bit of animation stuff, and if there's time, we can also get into textures and normal maps and materials and stuff. So that's a lot. So we're gonna start jumping in. Fortunately, though, it's not very codey today. It's just kind of like using Godot. Yeah, I'll start by breaking down this scene a little bit, and then we'll look at each of the nodes and components in examples that you can follow along with. So this scene is just a demo model scene that I found on Itch. Again, Itch is a great resource for finding free assets. I added some CSG shapes because it was only 3/4, but it basically looks like this, right? We've got these desks. We've got this window. It doesn't have a city in the background. I just added a city picture. And it doesn't look the best when you get up close, but right, if you put it far away, it's not too bad. So you can, parts of like, honestly, like so much of environmental design is like knowing when to cut corners and knowing how to like simplify your workflow. You don't need to build a whole city. Sometimes you just need a picture of a city in a background and put it at the right angle, and it can get the job done. Okay. But these are all just GLB models. So again, if you want to use models either from Blender or Cinema 4D or just from the internet, a great file format to use is GLB and GLTF files. That's a pretty standard file format these days. You can also use OBJ and DAE, but for instance, if I just open up this, and I'll put a link to this specific asset pack if you want to make a school thing, I guess. But right, here's the model itself in Godot's sort of weird little importer. It doesn't usually look this weird. I just have it super large so we can see the UI, right? But like this is the model of the desk or whatever. And then you can always just take your models and just drag them into your scenes. And there it is. So like literally instancing models into your scenes are pretty easy if you know the workflows for working with them and modeling them in other software. Okay. Any questions about models in particular? Great. Let's talk about lights. Okay, there's a couple different lighting things going on. There's several different ways to do lighting in Godot. Okay, so this is using, let's see. There are several different, I'll start with the types of lights. There are a couple different key types of lights. You can have a directional light, which is what we've been adding to our scenes all along. A directional light is a light source that is it's modeled to be infinitely far away, so no matter where you move it in the scene, it's not like it's going to get any closer to objects. really the only thing that matters is the angle that the light is at. So if I change it, you can sort of see the angle changing. So in order to create a directional light, I'll have a couple scenes open at the same time. That's what I'll do. So I'll make a new scene. I'll add just like a box, CSG box. I'm going to turn off the light in the environment, and then I'm just going to add a basic directional light. Oops. So directional light 3D, and you'll see suddenly right there is light. This object is lit up, and you can see that it's being lit up directly from the side, but if I were to change the angle of this, you can sort of see how it's impacted by lights and shadow. Does anybody have an idea why we would want a light that's infinitely far away?
The sun?
The sun, right. The sun is really, really, really far away, and for all intents and purposes, it's infinitely far away, like from a practical lighting perspective, and like moving it around horizontally, just in the way the sun moves, doesn't really do anything, but rotating it does, right? When the sun rises and sets, it sort of, the angle of it changes. And so directional lights are really good for kind of large ambient lighting things like the sun, or like in this scene, I've used it to create a moonlight. I think I also use it in this scene to create a little moonlight over here. This scene did look cool, and then I added this fog and I messed it up, so it doesn't look as good. But so directional lights are really good for creating sort of global light sources. Okay. The other type of light you have, another type of light you have, is called a spotlight. Does anybody know what a spotlight is? No? It's like a spotlight. Well, yeah. Like what's a spotlight?
It's like the highlight on stage where if somebody individually is standing there, you need to highlight.
Yeah, right. It's kind of like an area of a very specific area of light, right? So if I were to turn off this directional light, we're back here in shadow. I'll add a camera really quick so we can just see what it's going to look like. Here's the camera. I'll pull it over here so we can see the box. I'll just split the view really quick and make this one from the perspective of the camera. Then I'm going to rotate it and scooch it this way, and that's pretty good. So now, and I'll just do this as, so I'm going to save this in the root folder as in class example. Now when I run this scene, you'll see that it looks pretty much like garbage, right? But if you add a spotlight, I'm going to delete the directional light, and I will add a spotlight, and I'm going to make the view one thing again. I'm going to hide the output. I'm going to move the spotlight now over here, and you'll see that this spotlight has a pretty clear cone to it, okay? It has a light source and then a cone, and then you'll already start to see, as soon as it hits the surface, right, it starts to cast a little bit of light on it. And I can rotate this down, and then we have a pretty clear spotlight, actually. And I've sort of messed up the snapping, but that's fine. I don't need a call from Joe Biden right now. I will ignore that. Right, and so now when we run the scene, we can see that this surface has a nice soft light on it, right? And all these lights have different parameters that you can change and fiddle with, right? So you have the range. That's sort of how long this cone is, right? You have the attenuation. That's kind of how like sharp. You know what? I don't really know what attenuation is, but it does that effect. You can read all about it here. But if you just play with the curve, you can see pretty immediately the effects that it has. You can change the angle. So the angle is sort of how narrow or wide a cone it is. You can also adjust both the angle and the range by these little red dots. So you can do it kind of manually right here, right? That's just sort of weird. What's happening? There, I'll make the cone a little sharper. I'll pull it down a little bit. You can also, of course, change the color of the light. So now we have like a cool blue spotlight. Wow, blue. Right, and like, this doesn't look that cool because, again, it doesn't really have any environment. There's no sort of sense of like the world that this exists in. So if I want to make this look even more kind of like in a world, a really handy node that we've already been introduced to, but we'll spend more time digging into today is the environment. So I'm going to add the world environment node to this scene, but I'm going to do some stuff like changing the sky to just make it really dark. So I'm going to change the top color to like black, and I'll change the horizon to black. And you'll see that when we do it this way, when we start changing these, when we create an environment and then we change the environment variables, the objects in the scene, they pick up all the indirect lighting from the environment, and so it then actually looks a lot more like kind of like what you would imagine that it would look like, right? So now when we do this and we run this scene, it's pretty much a pitch black scene, right? Yeah, question.
Is there a way to disable that?
Disable what?
Like the objects being affected by like the world environment and the light?
But probably. That's a good question. Let me think about that.
Is that released what I was doing?
Yeah, there are a couple different ways you can do that. So you can, I believe, if you are to give it like a, let's see, no, there are ways to do it. They're slightly more complicated, but I will show you. Is anybody else interested in knowing about that? Okay, all right, fine. Then I'll do it now. So one way you could do that is by creating a. Let's see. I'm trying to figure this out as we do it. It's an interesting puzzle. I think you could do it by creating a viewport. A viewport is sort of like a window into another scene. Okay, that's going to sound abstract, but if we create a sub-viewport, and then we put this box beneath that sub-viewport, you'll see it kind of, is this actually going to work? Let's see. I'm going to make the sub-viewport its own world, and now you'll see, the box did disappear, right? It's no longer being rendered in this environment. It's being rendered in the sub-viewport environment. Then the question becomes, how do you display the sub-viewport back on the real world? I think a good way to do that is with a canvas layer, maybe. Canvas VAS layer. This is just a flat layer of rendering where you can draw stuff on top of a scene, basically. So you can like create your scene and then you can draw another layer of stuff on top of it. And then with the canvas layer, I think you can do maybe follow viewport. Maybe that's going to do it. What does this do? I don't know. No. I'm going to be honest, I was not prepared to answer this question today, but I'll have an answer for you after spring break. That'll give me plenty of time to figure out how to do this. How would you do that? It's really interesting because once you, the problem is, right, once you put things in an environment, they are kind of in the environment. So it is hard to, take them out of the context that you put them in. I'm gonna think about that. Does anybody have any questions that aren't gonna completely throw me off my game? No, I'm just messing. It is a really good question. It's a slightly more complicated workflow in order to have objects in a scene that respond to light and then have other things. Because what you're saying is, right, you want to have an object still be in the scene because you want to interact with it and see it, but you don't want it to be impacted by light and stuff. So that's kind of like that's a trickier question.
Because the project I'm working with is uses a lot of color,
Mm-hmm.
and sometimes the boxes go in front of each other, and then it puts a shadow on what's behind it. And
Mm-hmm.
just mess with the colors. That really helps.
Mm-hmm. Mm-hmm. Mm-hmm.
But
Yeah, I mean, if you, yeah, let's circle back to that if there's time at the end of the class, because there's a lot more stuff I want to show you all. But let me. Well, no, it's okay. It's a great question. I was not you caught me off guard. But I'll think about it. So we have a spotlight. We have the again, the spotlight has all these different parameters you can play with. Again, the directional light also has some of those parameters. So the directional light, for instance, has a light tab. It has a color too and an energy, so you can have like a pink sun or whatever. But you'll notice kind of as soon as we start getting it in here, what is happening here? Why is it weird? Okay, there it is. Right, there's our sun in the sky. There's our pink sun. And as soon as we start, as soon as we really bring it in here, it starts kind of totally dominating the scene. So unless you want sort of like a large global light source, just if you're doing anything interior, basically, use the directional light sparingly, because it'll really sort of take over all your lights. Another light we have is the OmniLight, OmniLight 3D. And the OmniLight 3D is, does anyone want to guess what the difference between the OmniLight is and the Spotlight? It's all over, right? It's omni. It's everywhere. It's a sphere. It's like a light bulb or a candle, right? And you can kind of tell from the icons, right? The spotlight looks like a stage spotlight. The light bulb emits light in a circular radius, so you can use that however you want. And it again has all these different properties that you can fiddle with. Okay. You can also use these lights as projectors. So if you give it a texture, it'll sort of emit that texture. And I'm gonna there's. Textures can be anything. Textures can be, let's just do a new, image texture, okay? And we'll bring in, if I click on this image, and then let's go find our robot maybe. I think we can bring in our robot. We'll bring in our city skyline. If I drop this in here, I think, then we should see, you might need to crank up the energy a lot. If you fiddle around with this, you can get it so that you kind of see an image of the texture projected from the actual light. But it's not really being nice right now. Why not? What did I do wrong today? Oh, you're mad. What are you mad about? It only works with shadows active. Okay, great. So, so then we just need to turn on shadows. So this is one way that solves sort of your problem. With certain lights, you can turn on or off shadows, like whether or not they actually cast shadows. And by default, they actually don't, because shadows are more computationally expensive. But when you turn on shadows, and then, what is happening, guys? Where is this light? Spotlight's gone. Oh, maybe we're out of range. Maybe we just need to get back on the ground. Yeah, there we go. You can kind of see on the ground now, right? It's like we've cast this light of this image onto the ground. So that's kind of a weird, fun effect you can do. And particularly if you use a more fitting texture, like a grungy texture, right? You can actually create some really interesting effects. I'll actually show you a very special type of texture that is going to be really helpful for you to use everywhere in life. Everywhere in life? I don't know about that. It's a little bit broad. But this is one of my favorite. This is one of the greatest tricks you can do in programming. Does anyone know the concept of like mathematical noise? Have you heard about noise before? Noise is like, I'll just show you what noise is. So you can create a noise texture here. You can also create noise textures in a lot of different places. So I'll show it to you here, and then I'll show it to you elsewhere. But you can go and create a noise texture. That's a special type of texture. And first you'll see it's pink, okay? You have to go and specify what type of noise you want to do. And you have a lot of different noise. Well, you have fast noise light. You click fast noise light. And then you'll see we create this weird, cool effect. What's going on here? I'm going to open up this resource. And you'll see your first kind of look at noise. Noise comes in many different mathematical types. This is a simple noise. You have Perlin noise is a very famous type of noise. And you can kind of control how far you zoom in and how far you zoom out. You can kind of scroll it and make offsets. You can change like how many noises are basically like mathematical fractals. You don't need to understand how this works. All you need to understand is that by playing with noise, you can create all sorts of really interesting natural things. So like, for instance, this sort of looks like a muddy puddle, right? Or clouds. Or if you were to, let's say, I'll make another quick scene example. 3D scene, I'll make a CSG box, SG box. I'll make it big. Nope, I'll just move it over. Okay, now I'll make it big. Then I'm going to go down to its material, give it a material. I'm going to open up its albedo. I'm going to give it a texture. I'm going to create a noise texture. I'm going to go down into wherever it went. I'm going to open up the noise itself. Go down and pick a noise. And then when I unselect it, okay, I've got this gray noise. That's kind of cool, I guess. But if I just change the colors of that noise, so for instance, if I just open up the noise and go to color remap and give it a gradient, and then I open up the gradient, and instead of black, I do like brown. Right? And then instead of brown, and instead of white, I do green. Kind of like a darker green. You'll see that suddenly, once I stop highlighting it, it looks kind of like grass, right? Kind of like a ground. Not the best ground, but it's a really cheap way to make like a pretty organic looking texture, right? You can also make like, and there's all sorts of different patterns you can get out of noise. So it's definitely a tangent, but like noise is like a great way to put your computer to sleep and also get sort of natural looking shapes and textures that you can then use in other areas. Okay? What is it? Animated texture. Yeah, so you can also have animated textures. And let's actually just start talking about, oh man, yeah. We'll come back to lights. We're going to zoom in on textures and materials for a little bit because that's another real key part of environments, right? So another type of texture you can have is an animated texture where you can go, let's see, we go back to the box. We go to our texture. I'm going to hit reset and change it to an animated texture. Now I'm going to open that up. The animated texture is a little bit clunky. You know, ideally, you'd be able to pick a whole movie file. It's not quite like that. You have to load in individual frames. But what you can do is you basically can load in as many frames as you want, and each of those are their own texture. So let's make like 3 different frames. And let's make the speed of those frames. Can I do this? There we go. The speed scale is like the animation speed, basically. So for frame 1, you see that right when I change this number, we add frames down here. So I'll just do 3 frames for now, and I'll just make textures. So I'll make the first texture this skyline. Oh God. Okay, hold on. Where did we go? I got lost. Help. Okay, This is one of the weirdest things about Godot, but we often, right, we have these nodes which have properties, and then you create these resources. So I've created a material, and then in here I've created a texture, which is in of itself a resource. You have to open that up. You just have to kind of get used to like opening up these menus inside of menus inside of menus. But now when we're here, I can drag this over to here. Oh my God, why can't I actually do that? There's another way to do it too without just dragging. So we'll try it one more time. Animated texture. I'll do quick load skyline PNG, and then we've loaded in our skyline. Okay, then I will load in the robot icon.svg, and then I will make the last one a noise texture, and we'll just make that one regular fast noise light. And you'll see that it basically just like doesn't do anything. Hello, there we go. It cycles through them, and it seems to be stuck right now. That might just be because we're previewing it. Oh, this is the wrong scene. If we were to run this scene, texture demo. We wouldn't see anything because we don't have a camera. I love life. Camera. Camera. You'll see that it's like more consistent, right? So it just sort of rotates through these different still images, basically. And you can speed them up or slow them down. And if you have like an animation, right, if you have like different frames of fire flickering or whatever, you can stack them all together and make it look like an animated texture. Cool? Yeah, while we're here, right, we're already looking at a resource called material. Right, we've looked at these, we have these boxes, and we've seen that boxes have this big thing, right? We have this geometry section, and we have this material override section. And we've done this thing where we've created like standard materials, okay? And materials have a lot of different settings that you can sort of configure. And I'll show you an example of like a material. When you sort of spend some time configuring things, you can make kind of more complicated textures and stuff. So like here, for instance, you can see here, and again, I'm not like a pro at any of this stuff, and it looks bad here because we don't really have any lights. But if you look over here, right, you can see that this has like, it's clear and it bounces the light off of each of the bubbles. This is kind of like a basic bubble wrap texture. And the way that we kind of accomplish this effect, where we sort of have this like this material that has this height to it, is by playing with a couple different layers. So for starters, in the you can play with the transparency of a material. So you can sort of make it either transparent or not. Okay, and when you play with the transparency, right, that affects how it blends with things behind it. That actually looks more like bubble wrap. You can also play with the, let's make it not blue. It's sort of annoying that it's always blue because you kind of want to see what you're doing. But you can play with an albedo, right? Albedo is sort of like the main kind of like light color that is emitted basically from a material. Albedos have color and texture. You can also give things a metallic quality by playing with that, and you want to give it sort of a metallic map. And oftentimes when you get sort of high quality textures, they have all these different they have different images that you combine together to make these different materials. So you use like a roughness map. You can see that you see this file path. We have textures, 4K, plastic, bubble wrap, roughness, JPEG. I'll show you in the folder. Actually, that'll make more sense. So here in this 4K pack, oh, it's so tiny though. let's do plastic. So you'll see that, right, this is this sort of rubber texture, and you'll see that it has like a normal, you'll see it, right, we see how we have like 4 different versions of the same image. We see the black and white one, and the blue and the gray one, and the color one, and then the purpley one, right? We see how they're all the same image. Y'all still with me?
Yes.
Is this too much? We did. I can stop. I can not do this. But these are different layers, right? And this is like, this layer controls, you feed this image into your material setting, and this tells it how light bounces off of it. Okay, that's what a normal map is. A normal map instructs a material and tells you how it interacts with light. The roughness, the metallic map tells you which parts of it should be metallic. For this rubber map, none of it should be metallic. For the height map, right, this sort of shows you how bumpy it is. And for the glossiness, this shows you how shiny it is, right? And so when you feed all of these things together, I actually think I did that one, so I'll switch it. You create, boop, 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 boop. Stuff that like feels actually a little bit more like it exists in an environment, right? You can kind of see that here, right? We can see the way it reflects the light off of the environment itself. And so again, how you do that in Godot is you create a material, and then you import all of these different images and stuff into these respective channels. So for metallic, you import in the metallic texture. You drag that image in here. For the roughness, you drag in your roughness texture. For your normal map, you drag in your normal map texture. And then you can play with all of these different material settings to give it different looks. So like clear coat is like a shininess layer, so you can turn that off, and it will look less shiny. So you can really fiddle with all this stuff to create some of those like very realistic type textures. Any questions about that? So that's kind of like materials. We did a little bit of stuff on lights. So again, we have with lights, you have a directional light, an omnidirectional light, and a spotlight. And the easiest way to do that is to like set them up is to literally just drag them into your scene and use a world environment. And then once you have a world environment, things just start bouncing around pretty nicely. And if you don't do anything, it does what's called dynamic lighting, which is where the computer is sort of calculating all the light values in real time, which is very performant or is very responsive. But if you're using older hardware and stuff, it can slow it down, and it can be very costly in terms of like, you know, how bogged down your computer gets. So if you want to have a more efficient lighting model, you can use something called voxel-based lighting. For the sake of time, I'm not really going to explain what that is, but just know that if you make a lighting scene and your computer is starting to explode, explore voxel-based lighting, or come to me and I'll show you ways to optimize your lighting. Other really easy tricks you can do to like create more of an immersive environment is to just add fog. Fog is a beautiful thing. There's several different types of fog. There's just simple fog, which you can turn on, and then it has color to it and a depth. So it has this sort of color property and this density property, right? And the denser it gets, right, the thicker the fog is. So there's simple fog, and then there's also volumetric fog. Volumetric fog is like pretty spicy. I don't know why. That's so probably because we have this weird light. Let's turn on the spotlight and turn off the directional light. Oh no, nope, that's the wrong one. That's the sun. The Omni light. There we go. Go away. So volumetric fog is basically just like you have a little bit more control over it. You can make it sort of denser. If you want to actually see it, you need to turn up the emission, and then you can start to see things. And similarly, you want to crank up the density, and then you can really start playing around. And you can have fog of all sorts of different colors. You can also create fog volumes, local areas of fog. This is a node. It's just called fog volume. And it is right over here in this scene. You can just see it's like a box of fog, and you can make whatever shape you want. You can make it as thick as you want. And in this particular scene, I've tied its density. I've put on an animation that triggers when you enter an area. So when you walk over to here, it gets triggered and the fog dissipates, and you can see down the alley, right? That's a really simple example, but like by having these areas, right? This sort of, the way this works is you have this, let me just hide the buildings and the lights. You have an entrance area, which is an area 3D, and it has a collision shape. And then the script is very simple on it. All it says is we use the body entered signal, and then when a body enters the area, we say if it's the player. And I also added a variable that says scene started, which is false. So if the player enters the area and the scene hasn't already started, then we're gonna set scene started to true. And we do this so that we can't trigger the same animation twice, right? If you want things to only happen once, this is a great pattern for only making things happen once. And then you do animation.player.play, the name of the animation. And the animation player just has this animation that changes the density of the fog. And you can animate any properties of any nodes as well. So you could really animate like lights moving around or objects moving through space. That's a really simple way to create sort of like a responsive environment. I know I'm sort of cramming a lot in here. I apologize if it's brain melty. Are there any questions about like, are there any questions? Or are brains totally melted? A little melted. Okay, well then let's just melt them even more. I'll show you even more stuff. No, I think we'll stop soon. Is there anything really important to know? While we're on I guess this is kind of handy to know. Materials can also be emissive, so you can have a material actually emit light just as a material. So if we look at this street lamp scene, you'll see that this light is actually bright, and when we run the main scene, if we go over to the street lamp and look at it, you'll see that it kind of has light coming out of it. It's kind of hard to tell right now on the screen, but it does actually emit light. Just believe me. And the way that you give a material an emission property is you just go to, it's back in the material tab. Whatever. It's somewhere. I'll do it on this in-class example. If we want to make this box glow, for instance, you just go to its material. It doesn't have a material. It doesn't have material. Look at that, folks. You give it a material. You go down to emission, and you say yes, please. And then you pick the color that you want to be emitted, and then how intense that color is. And you'll see that now we're sort of suddenly glowing. And it doesn't really look like glowing, right? It sort of just looks like you're changing color. So that's also to answer your question from earlier, how do you make something that ignores the environment? This is kind of one way to do that. But it doesn't really look like it's glowing at all. So in order to really get the sense of glowing, what you can do is go back to your world environment, and you can turn on some glow. So we already have glow, but oh my god, the computer's also done with me talking. We're so close, guys. We're so close. I do it all for you. Okay, so you just turn up the intensity of the glow, and you basically can play with these these little sliders and stuff, and then you'll see your thing starts to feel more like it's actually glowing. Nope, that just looks really black. Turn up bloom, maybe? You kind of just have to fiddle with sliders and still it starts to look nice. And also, frankly, like, this scene composition is not great because it's just like a big glowing thing. But maybe if I turn back on fog, it'll look a little glowy. I'll make it a little less dense. I'll make it less emissive. Let's see what that looks like. You can kind of tell that we're glowing, right? We're pretty close to it. Let's go way further back. Yeah, it's sort of glowing. What else is important to know? Playing audio is really easy. This is really a no-brainer. So I know we have no brains left, but you don't even need a brain to do this one. All you do is you just create a node called Audio Stream Player, and then you give it a sound file. So, for instance, here we are in our city scene. I'm just going to add a node, Audio Stream Player, 3D. And I'm going to give it a sound file. I'll just do stream, quick load. I'll just do this air conditioner sound that I had from earlier, and then I'll just put it in the scene. And you'll notice it has a position, right? And that's kind of interesting, right? Why does our sound have a position? Let's see if it does it automatically. Here I am. Oh, and you also, what you need to do is tell it to start playing automatically. So click autoplay 1. And then you'll hear that it's already started. Is it still going? Panning, distance, stream, playing, volume, inverse. It's so quiet. Where'd it go? Let's try it again. There we go. And you can tell already it is localized. So it's smart enough to know that, like, wherever your camera, I think it's by default where the camera is coming from, however close the camera is to the place in space, it makes it sound like it's nearer or further from that. So a really great way to get environmental effects is to just take some audio and put it into space. And you can already sort of have like a slightly immersive thing, right? Obviously, an air conditioner in the middle of an alley doesn't really tell you a story of anything cohesive, but I'm sure you can use your design brains and figure out good ways to place audio in space that does add up to something. Any audio questions? Yeah.
Is there, in scripts, is there a method that reacts to like sound?
Yeah. What part of sound?
So like let's say you want something to change up like the pitch.
Yeah. So we have this pitch scale right here, right? And so that's also just a property that you can play with on its own. So I can just set that to this, right? And now suddenly when we play it, it's going to sound a lot higher, right? And that is a property that you can also just change via script. So if you're here at the entrance, this is my entrance area script. So when I enter the area, I'm going to say, I'm gonna say audio, or I'm gonna say, well, I'll just drag this out over to here, and this shows me this. By dragging it out from there, that gives you the emojis. No, it gives you the correct file, like tree path to it, so you can access it. Then you can just say dot pitch scale, I believe. When you do it like this, though, it's not going to autocomplete. So what I'll actually do is just drag it up to here and do control. Now we have a variable. I'll paste the name of that variable. Now I can do dot pitch scale, and I'll set the pitch scale to 10. Right, and so now we'll see that when the game starts, it's at this pitch, but when I enter the area, it breaks because it's not a function, it's a property. So instead of doing this parentheses notation, what you want to do is say equals 10. Because it's just a number that you set. It's not like a function that does something. And there you go. Yeah.
Is there a way to define how long a song plays?
Yes. A good way, I mean, so for starters, you can just change the length of your MP3 file, right? If you have a shorter file, it can just play till it's done. And then I'm also kind of brain dead, so I'm not remembering the way to make sure that it doesn't repeat, but that has to be a thing. I'm going to do loop. Or, yeah, I don't know why I can't. I'm blanking on how to make sure it loops or doesn't. But another way to define a length is what you could do is you can have a timer node. So if you use the timer, have we talked about timer yet?
Yes.
Yeah, timer's just like this second countdown. So you could say like, you know, maybe you only want it to play for 5 seconds. So what you can do is say, you can say, let's go back to our code, right? When we start playing the thing, let's also just start the timer. So I'll start the timer by dragging in the name of the timer and then hit, I'll say dot start. And then for the timer, what I'll do is I'll just go to its signal, and when it's done being a timer, when it's timed out, I'll just go back to the same script. And we've created, right? This is, again, connecting a signal to a script like we've talked about. And now here, I'll just say, I'll say audio stream player dot stop. And so now, right, when we start it, it's going to start this timer. The timer's going to go, and then when the timer's done, it's going to call back to here and stop the playing. There you go. You can also do it through an animation player, but I know that it's 610, so we'll stop there. But basically, all you need to do is say, like, you would start an animation by playing it, and then you can also stop an animation with your animation. So you would make, like, a 10-second animation, and when it ended, you would, one of the points in the animation would be to pause the music. Cool? Great. Thank you so much, guys. Thanks for hanging in there. Have a great spring break. Have a lot of fun. Don't do too much homework. But feel free to contact me. I'm going to have the Oculuses on Thursday. I'm going to be doing them here. You can experience the wonders of augmented reality. Yeah, contact me if you have any questions about any of the labs. Again, there's no explicit homework except for to get caught up on stuff you haven't done and to try and come into next class with some sort of minimum viable product of like an interaction that you can start building out in Godot. We're going to start trying to make a lot of these classes working time on the project. So bring in stuff to work on, basically. But other than that, please have a good spring break, and I will see you in 2 weeks. What's up?
some questions.
Yeah, yeah, yeah. Hit me.
So what I meant by that question was
Yeah.
this.
Yeah,
Can you make something like reactive to it, like the
Reactive to
box,
what?
Like change size when it reaches a certain pitch, like in
Ah.
the audio file,
Oh,
or is that not something that is?
I have my class in the photo building.
yeah. Audio reactive stuff is a little harder in Godot. I don't know immediately. My gut impulse is that that's harder to do in Godot, but let me do some research.
Okay.
And talk to you later.
Sorry, I have a list of
Is
questions.
there any other day apart from Thursday when
Yeah.
you're here
For
for us to like try the equipment? Because Thursday I'm working all day, so I can't come.
this week or in general?
Either or.
Okay. In general, I could do like Tuesdays before class.
Mhm.
Does that work?
Yeah.
So why don't we try for that?
Okay.
Other than that, I'm pretty sure that you can, if you just go to DIC and ask them to check out the Oculus headset, I think
Yeah.
they will let you do it. And you can tell them that you're in my class.
Yeah. Okay. Sounds good.
Cool. Great. But yeah, would you want to try out stuff
Yeah.
in person?
Yeah, I do.
Okay. And are you okay to wait until after spring break, or?
Yeah.
Okay. So let's shoot me an email and I can set up a time before class on Tuesday.
Okay. Yeah.
Cool.
Sounds good. Thank you.
Yeah.
Okay.
Thank you.
Yeah. Thank you. Have a good break.
My biggest question, which
Yeah.
is how to make each box is unique. So-
How to make each box unique.
So like last week,
Right.
I don't really remember what I had, but so then I have all of these boxes,
Right.
and they're attached to one script,
Mm-hmm.
and the materials. Okay, so I make it unique, and that works. And this is what I have.
Wow. Cool.
Thank you.
That's fun. I really like that.
Thank you.
Hell yeah. Sick. Whoa. Cool. How did that happen? What happened?
So right now I'm just testing forums. And like different
No, I love
colors.
that. But like, how is it changing from different things? What are you doing to change?
Oh. I just I tried getting into the timers, but instead of using timers,
Hope you don't go though.
I'm just using
I don't know. Or hope you go.
what is
Oh
it?
yeah, I'll see.
Oh, I'm using this
I'm
variable,
pressing.
and then I minus one, and then it's
Yeah, but are you just
basically
making them? You're making them. You're just
Yeah,
toggling their
yeah, yeah,
visibility.
their visibility.
Sick. That's great. I love it.
So that's really easy. But,
Yeah,
but so
cool.
then basically it's like
I'm really impressed with how far you've come. This is like
oh thank you.
last week. It was just a couple of red squares. It's really cool.
I think this random function that I found online was really useful.
Yeah. Yeah.
But okay, so there's like a lot of things that I don't understand. But like
Yeah. Sure.
all right, so right now I have this script B1,
Mhm.
and this is for all the B's,
Okay.
and it's affecting all of these, right?
Mhm.
But so then I guess okay, then the material thing is something that is like it affects all of them. Like I have to make each of them unique for them to change colors. Does that? But then like
But so
then the
well,
X
'cause
and
what
Y
do you-
is fine.
Cause you just want to change the color of it, right?
Yeah.
Have you heard of shaders?
Shaders.
Yeah.
Like in here.
Or just in here, or because you've done some touch designer stuff.
No, that was Dominic.
Okay.
Yeah.
Yeah, I think shaders are probably gonna be where you're gonna start
Is there a code?
freaking out.
Is there like a GD script code where it just says like make each of these things unique? Do you know what I mean? Or like, it's also annoying because these guys. Oh, okay, that's another.
Because talk to me about like, I'm hearing you sort of say like some of the things that you are struggling with, but like, what do you want to accomplish? Tell me what your goal is for, what you're trying to achieve
right.
that you can't achieve right now.
So it's material albedo color. That's the things that's making all of them random colors.
Cool.
So if we get rid of these, it's from a range from like -10 to 10.
Uh-huh.
So each. Oh wait. Why are they unique right now? I think I think I went in and then I made some of them unique.
Mm-hmm.
But then when I change the code, it gets rid of them all being unique.
Oh, that's annoying.
So then I have to go in again every time I change code.
Yeah, you shouldn't have to do that.
I don't know why it does that.
Because you just want to, what you're saying is you want to be able to change your code and also just change the colors of these things
Yeah.
via code. And ideally, you just want them all to have different colors, right?
Also, the what's this called? This is an RBG, right? I forgot what you said about.
Yeah, it's it should be RBG. It might be RGBA. So if you want to check what it is, one of the easiest things to do is hold down Command, I think, and then mouse over albedo color.
Oh, because this is a variable that won't show it. This
Or
is like
actually, you can another way to search this sort of stuff is just by searching the built-in docs. So if you do search help, you can click on search help up there.
Yeah.
Then just search like albedo color. Just type in material dot albedo color, I think.
Color.
Yeah, let's try opening that up.
Bye, John.
Bye. Have a great break.
Thank you. You too.
So so this says the default is, this shows you the default. So it's a color value of 4 values. So RGB and A.
So I'm guessing that this is like hue or something.
So A is alpha, and that means transparency.
Oh, transparency.
Yeah.
Oh, that's actually really helpful.
Yeah.
Okay.
Yeah, and I forget if it's ARGB or RGBA.
Okay.
But if you just play around, you'll figure it out. I think it's RGBA.
Also, I had a question about floats. Float
Okay,
values. What does that mean?
Yeah, so so floating point numbers are like decimals, basically. So like 1.5 or 1.2, whereas integers are just whole numbers like 1, 2, 3, or 4. So they're anything with a decimal point, basically.
Okay.
Why are you asking?
Because there was an error, or no, when I was trying to figure out, I forget which one it was. I think it was when I was trying to figure out. Oh wait, no, it's in test. This one. Which one was I trying to?
Also, let me just Google this question because it's an interesting question about like how do you actually change? What's the best way to change colors? What is the easiest way to change a 3D object's color in Godot 4 via code? Yeah, no, I know that.
Dang, I forgot. But there was one method that said like I wasn't using floating properties correctly or some shit.
A floating point number?
Yeah.
Correctly? Is it in your errors? Is that?
No, I think maybe I deleted that script, but like, what I just had to change was putting the value in like parentheses instead of being equal. If that makes sense.
Yeah. So
If I run into it again. Maybe.
So sometimes, right, like what I just ran into in class is I was
Yeah,
trying to set a property of a thing by using a function. Like confusing, the difference between, right, functions are like actions that things can go and do, right? Whereas like a property is just like a value that you set. So whenever you set a property, you want to use equal. And whenever you use a function, you need to use parentheses because inside of those parentheses, sometimes you put in arguments, which are like special instructions for the function.
But okay, yeah, that makes sense. Because I was gonna say something about color. But
Yeah. No, that's a good question. Like, right? What is this? This is a What is color? Why don't you right click in color and let's find out. So, or command click. Or you can actually, you could try, command click. So color.
Cool.
Yeah.
Oh, I had no idea. I was searching it in here the other time.
Yeah. So, so it's a class. Classes are, don't worry about it. But when we create a class, you're technically, like when you are creating, so, okay. what's a class? A class is kind of like a it's like a template. It's like it's a specific type of data and functionality that's all grouped together.
Mm-hmm.
So we have a class for colors, and
Mm-hmm.
colors have these properties, and they also have methods. Let's see. Yeah, colors also have some methods, right? So like colors can do all these things, right? And basically, when you create an instance of a class, you use something called a constructor function. And what that means is like you basically write the name of the class in all caps, and then you do parentheses, and you give any arguments to it, and it's going to spit out an instance of that class. So that's all super abstract. But if you go back to your script, I can show you. Like right here, it's the same thing with vector, right? Right here, we're creating a vector 3. And so we're saying, let's make a new vector 3 with these 3 numbers. So we are doing a function, but we're creating a class. We're creating a data type. And like right here, we're creating a color, and we're using these 3 parts of the color. We're doing this color, create a new color function, and then we're setting this material.albedo color to the results of that.
Right.
Does that make sense?
So not really. But
Not really. It's okay.
Yeah.
Basically, like, all that is to say is that when there are parentheses, it is a function. So this is technically like a function that's doing a thing, and what it's doing is creating a color, and this is creating a vector, and this function is picking a random number between 1 and 4, right? A random floating point number between 1 and 4.
Okay, so then. Okay, so I thought like I was looking around. I tried doing this access as unique name, and I thought that would maybe make all of these unique.
Yeah.
But I have
No, it's access. Don't worry about access.
Okay.
It's
because there aren't they already unique names.
they seem pretty unique, right?
Yeah,
the
so
problem
confused.
is I believe that the material you're using is the same material. It's like one instance of the material.
So if I change like the hue of all of these, would that do it? Like if I made this guy like slightly like wider by like
try it.
one. Okay, then I have to go into.
So one thing you can do is actually like you can make things unique all at the same time. So with the UI, so if you so you can
like
do that.
This?
Yeah.
It doesn't work.
Oh, it doesn't work?
Yeah.
That's annoying.
Yeah.
it doesn't work.
These are only changing like sometimes if it's angled down, it's like a slightly different color.
Yeah. Yeah, that doesn't work.
I'll try the hue thing.
Sorry, what is this? Okay, I don't care about that. That's just spam. Problem is, I have many different meshes that have many different materials that all need to be unique.
Is that Siri?
So this is a thing called Perplexity. It's a combination of both. It's like it's a GPT powered search engine, so it both has the like flexibility of being able to work with like natural language, but it also actually does search engine stuff and gives you not bullshit results.
Right.
Yeah.
Okay, one last thing.
And also what we can do is do you want to schedule a time to do some office hours, and I can like if we schedule something, I can like I'll come in with an answer. Just
Okay.
The problem is I keep like meaning to look into this more specifically, but all the class prep just gets in the way. But if we if you want to pick a time to meet, we can like really figure that out in that time. Would that be helpful?
The Thursdays I have class.
Yeah, I can do any day of the week. That's fine.
Oh, okay.
Yeah.
Then maybe after spring break.
After spring break? Okay. Yeah, that's fine.
One quick question.
Yeah, totally.
So right now I'm using boxes for all of these.
Yeah.
If I were to apply to a script to this parent node, would that be easier? And then could I say like, oh, in here like make each of these like like make each of these things do different.
Yeah,
Can I
you
do
know
that?
what? We haven't even. Man, this class is so weird because it's like there's all this you know,
Coding stuff,
well,
or-
there's all this XR stuff that I need to try and talk about, but like there's also some really fundamental coding things that I haven't been able to tell you about.
Right.
So, for instance, do you know about a for loop?
Nope.
Great. So go ahead and
Should I start a new file?
make a new script on this box too.
Okay.
Yeah. So create a new script. Now we can just do this in the ready function. You can say so a for loop. What a for loop typically looks like is you say like I really got to teach you guys about for loops. That's a big oversight. For loop. But you don't really need them until you're trying to do something like this. So
Oh man. Okay.
so a for loop is like not a great diagram. Basically, yeah, okay. No, not a great diagram. Not a nested for loop. We just want a regular for loop. This is kind of good. You basically say for every single instance of a thing in this group of things, do all of this. Okay? So, I'll show you in Godot. I think Godot will be a little bit easier. So also, all right. So if you have another sort of fundamental data type that you have in all programming is an idea of an array. An array is just a list of things. So like, for instance, I'll make a new script. I'll call this array and loop demo, and this will be a scene. Okay, wait, hold on, cancel. Let me call this node array loop demo. Then I can hit return and save the scene as array loop demo. So this will be in this folder in that part of the repository. If you want to look it up later, I'll attach a new script that'll also be called array loop demo. Okay, so here we have a script. So this is I'm gonna create a new variable called my array. So anything can be a variable, right? Array, say equals.
It's a VER.
Oh, yeah, you're right. All right, so my array is going to be equal to, and then this is the syntax. You do bracket, and then you do your first thing, comma, your second thing, comma, your third thing, your fourth thing, and it can be anything, right? You can do strings, string. You can do a Boolean, right? You can do all sorts of stuff.
Oh, Boolean? I was confused by that, but that's just true or false, right?
Boolean is just true or false, yeah. And so now, down here, I'm going to do print out. Nope, come on. Print my array.
Right.
Okay, right? And then when we do that and we run this scene, you'll see it prints out the whole array, right? It just prints out this whole list, right? What you can also do with arrays is you can access any individual piece of the array by going like this. You can say, let me get the first thing in the array. Okay, and so now when I run the scene, it's actually probably going to give you the second number because it starts at 0. So it goes 0, 1, 2, 3, 4, 5. So I can do 0, 1, 2, 3, 4, 5. I'll do the sixth, and it should print out my string. Nope, why not? 0, 1, 2, 3, 4. Oh no, sorry, I'm counting wrong. I'm counting bad. I'm going to print out the fourth thing, and it's going to print out my string, right? But again, right, because arrays can be anything, and because you can reference, because you can also access like nodes with your code.
I can do something like this. Where I just drag this into it. And that's another.
Kinda, yeah. And
then
also,
I could say-
an even easier way to do that, so if you want to have a bajillion of those and you don't want to have to do it every single time, you can just do, first you're going to want to create the array, and leave it just blank when you create it. because coding is all about like figuring out how to do the least amount of typing possible, and like everything you can, all these questions you're asking are like, how do I not have to type this 100 times?
Right.
There's
yeah.
always a coding solution, and the way you like, the more you do it, the better, the more efficient you can get, the less work you can do, and then the more flexible your code actually is if you make changes and stuff. So what you can do, first you need to declare it up here, then you need to do this inside the ready function, because what happens is like Godot, when it loads a scene, it loads in all of the nodes, and then it goes back to the top, and once it's loaded in all of its children, then the ready the ready function executes. So I'm just going to create a couple blank nodes, and I'm going to say my array equals, and then all nodes have this function built in. You can just say get children. And this is going to return an array of all of the children of the current node.
Whoa.
And so now you can just do print my array. And then when you run it, you'll get, you'll see this weird sort of syntax, but you'll see here's the names and references of all the different nodes in the, this is what the computer is understanding them as. These are all the names of the nodes. And so then what you can do, once you sort of get all your children, you have this array filled of the children, then you can do stuff with them. So you can say for, and this is how you do a for loop in Godot. You say for child in, and then you give it the array that you want to execute over. So I'm going to say for child in my array, and you do colon, and then beneath it indented, you can just do stuff with the children. So I'll just do child dot show, or I'll do child dot hide. And now, well, you're not going to be able to see because they're in just nodes. I'll just print out the name of them. I'll say child. I'll say print child dot name. Name is the property that is like this specific string of text.
Right.
So now we should see, right? It prints out the names of the things, but also like if they were like physical things,
I'd be able to change the property.
you could change any of the properties. So and you could do that in the ready function. You can also do that. Where did it go?
Okay.
Yeah, I lost it. Sometimes you lose things. There we go. You can do it in the ready function. You can also do it in the process function. Like you could change every single child's position in your process function, for instance.
Child
In the array, yeah. So if you did
so
something
child,
like
child, there's something built in as well.
this can be any word you want. You could just call it kid. It can
okay.
it can be dog. But then in order to access the element, it just needs to match, right?
Okay.
So like then you just do dog.
But but 4 is specifically for.
Yeah, you're right. These right, and that's how you can tell, right? Any of the colored words, they mean stuff, right?
Yeah.
So for and in, these are like special keywords that the computer's going to recognize and see. So you say for, then you say the name of the thing that you want to grab an instance of, and then you use the array of stuff that you're going to iterate over. Cool?
Okay. Yeah. I'll keep testing.
Yeah, try this stuff out. I'll put this in the repo, and I'm just gonna quickly change each of these to like spheres. And see, this is the thing, right? Like, what's nice about doing it this way is instead of having to change it all by hand, it's still gonna work, right? And so now I'll say like, we'll do this. I'll do for child and array. I'll do child dot position dot x equals randiff range -5 +5. I love these randiff ranges. They're so handy. It's really, really good. And so then now I can save that, and we just need a camera, which we don't want to. let's do this. Let's make a new scene because we can't, right? We don't want to have the camera also get moved around.
Yeah.
So what I'm going to do now is create a new scene, a 3D scene with our standard stuff. I'll just give it a sun so we can see, and a camera. And then I'll instance in the child scene of, oh my god, array loop demo. There it is. We'll move it way over here, and then when we run it, this will just be camera. Oh my god. Camera array test.tscn. Okay. Right, it moves them all randomly.
And this is in setup or whatever.
This is in setup, so if you just did it in process, it would do the exact same thing, except you can kind of maybe guess what'll happen.
It'll just jump around.
Yeah, it looks kind of cool actually. We can just do like, I'll just paste it in there.
So I want to
Oops.
maybe like build something really big with this.
Uh-huh.
But then I get kind of worried about like the what's the word? Like the optimizing. Like would it get super laggy with just a shit ton of like
Well,
boxes?
I mean, you kind of want to, just start doing it until it gets laggy, and then once it
Okay.
gets laggy, then you can start figuring it out.
Okay.
Something immediately that you can do if you are worried about things getting laggy, using the CSG shapes is not the most performant.
Okay.
They're mainly
Yeah,
designed for
that was kind of-
prototyping.
mhm.
What you can do instead is, instead of a CSG shape, you can just do a mesh instance. Mesh instance, 3D. And that doesn't have the built-in collision shapes, which you might not need if you're just doing visual stuff. But for mesh instance, you just want to give it a mesh. You can pick any of the meshes. And then this already is going to be a lot more performant. You're not really going to be able to tell. All right, this isn't even the demo scene. I don't think anything that we've done is going to, you're not going to be able to see any difference. But let me start closing some of this stuff.
Can I just ask one more?
Yeah, totally.
Okay, so the function, the process function.
Yeah.
It's 60 frames a second, right? But that's too fast for me. Is there a way to slow that down? Oh, or should I just do like an if statement with a variable that's on like a timer, and then like it hits it?
You could do that. In even simpler ways, you can say, you can do like, I'll call this I'll make a variable here called counter. I'll make it equal to 0. Every single time we go through the process function, I'm gonna increase the counter. So counter plus equals 1. And actually what I'll do is I'll export a variable over here, export, and I'll call this I'll call this threshold, but you can call it whatever makes sense for you. With an E, and I'll make it currently equal to 5. And then I'll say if counter is greater than or equal to threshold. Oh, I didn't do this right. Oh, come on. If it's greater than or equal to threshold, then do all this stuff. And the last part that's really important is we have to then reset the counter back to 0. And so now it should happen every 5 frames, right? Every time, every 5 times.
Oh, because it's when it's more than threshold. Okay, I see.
Yeah. Oh, and gosh darn it, it's over here. Texture demo. But what's fun about this, right, is
Can I take a picture of that? Sorry.
yeah, totally. 1 second. Can you see it?
Yes.
Cool. What's fun? What is fun about this? This is not this. this is not this. Where did the thing that we just did go? Camera array test. Okay, right. So we're here, right? When you like, let's say you're doing this and you have like 6 different versions of this code, right? Right here we have our thing. We have this regular scene. We can run it. Here we have this one that's going every 5. But maybe I want to have like, 3 of these, and I want to have them going at different speeds. And you don't even have to go into the code, I can just change the threshold from here. So I'll make this one change really quickly. I'll make this one change at 5, and I'll make this one change every 50, right?
Oh, they keep the thing in instance.
Because when you have a scene, right, that has a script attached to it and an exported variable, when you bring in that scene, you can just access the variable from here. So you can kind of like abstract things and tuck them away, and you can edit this really easily, right? I can be like, actually, this is not slow enough, so let's make it 500, and then just see it again.
Okay.
Cool.
Yes.
Sweet. And damn it, I will figure out how to make unique colors. It's got to be easy. It's silly that it's kind of hard, but it's really easy with 2D stuff. But once you start bringing in materials, it gets a little bit more complicated. So by the end of the week, I'll send you something.
Okay.
Yeah.
And I'll try coming to more office hours.
That sounds good. Yeah, just shoot me. Just let me know, and we'll schedule them.
Okay.
Oh my God, and I'm still recording the freaking video.
Oh man.
It's gonna be. Hi guys, thanks for hanging in there for all of these questions.
Thank you.
Yeah. Have a good spring break. How do I stop?